All right, now we're looking at section 7.8, and our learning targets are first we're going to learn how to factor polynomials by grouping, then we're going to go through some factoring polynomials completely, and then we're going to use this factoring to solve some real-life problems. So when I factor by grouping, I can do this when I have 4 terms. I first want to group them into pairs, and then figure out what's in each pair that I can group out. So let's look at an example. So I want to factor each polynomial by grouping. So one thing I like to make sure is that everything has a plus in between it. Even if I have to change it to a negative, I can do that. So then I notice I look at my first group and I look at my second group. So I see here in this first group I can factor out an x squared because there's 2 x's here and there's 3 here. So when I factor out that x squared, then I'm left with 1x plus 3. In my parentheses, right? So I've taken out the common terms that are in each of my terms there. So then in my second group, I see that each of my numbers is divisible by 2. So I'm going to go ahead and factor out that 2. So then I'm left with 2x divided by 2 is x, and 6 divided by 2 is 3. So now I notice that the things in my parentheses are exactly the same. And in order to factor by grouping, the things, they have to be exactly the same, or I've done something wrong. So now I can write out my factored polynomial. So now I have my x plus 3, the thing that's in the parentheses, and then the second part becomes everything that was outside of the parentheses. So I end up with x squared plus 2. So often you've been given this, right? This blue and purple one. So now we can, now we're just working the other way. So if I was to, let me just move the order of the, oh, never mind. So if I was to give you this part, the solution that we came up with, and said multiply, you would write it like x squared times the entire thing plus a second term times the entire thing. So all we're doing is we're just working backwards to factor things. So now I just want to make sure we're factored completely, and I see that there's nothing left that I can factor out of either of these 2 terms. So let's look at B. So I see I have x squared plus y plus xy. Well, if I was to just group them, I don't have anything common that I can take out of this first batch. So I need to rearrange the terms. So I'm going to rearrange them. So I've got x squared plus x plus y plus xy. Right? So now I have some stuff with x's near the beginning and some stuff with y's near the end. So now I see I can factor out an x from my first grouping. So I'm going to be left with x plus 1. Then I notice I can factor out a y from my second grouping, so I'm left with 1 plus x. So I notice that the things in my groupings are not exactly the same. However, since I'm adding, I can rearrange them. So I know that 1 plus x is the same thing as x plus 1. So I can go ahead and rewrite that. So I'm left with my x plus y, right? The 2 things that are outside my parentheses, and then my things that were in the parentheses, right? And those are the same, so I just rewrite them here. So if I was to rewrite this, if I was to multiply this out, I would end up back with where I started. So I can take the terms in my polynomial and rearrange them in order to get them in an order where I can group them. So here are some that I want you to practice and see how you do with those. So now here are our guidelines for factoring completely, right? Because we want to get it as factored as we can. So the first thing I always want to do is factor out the greatest common monomial factor. Is there something I can factor out of each term first? So then, once I've done that, now I look for my patterns, right? I look for my difference of 2 squares or my perfect square trinomials. If I see that, then I can factor it a lot more simply. If I can't see that, then I go ahead and I factor like I have been before, right? So I end up with factoring my trinomials. So if you need help revisiting this, this is going to be a big key in what we're doing in coming units. So then if I can't factor a trinomial, then I look at factoring by grouping. Okay, so let's look at a couple of examples here. So first thing I want to do when I factor is I want to pull out the greatest monomial factor. So I see that each term is divisible by 3. So I'm going to go ahead and pull that 3 out. So 3x cubed divided by 3, I end up with x cubed, plus 2x squared minus 6x. So I look and I just double check. Well, now I also notice that each term has an x, so I can go ahead and factor that x out as well. So now I'm left with x squared plus 2x minus 6. So now I want to go ahead and factor my trinomial. So I first want to look at all of my possible factor pairs of a negative 6. So I could have a negative 1 times a positive 6, or I could have 1 times a negative 6. I could have negative 2 times a positive 3, or 2 times a negative 3. So now I'm going to find the sum of these, and I end up with a negative 7, and nope, I'm sorry, when I'm adding, I end up with 5. Here I end up with a negative 5, here I have 1, and here I have a negative 1. So now that I know I have all these factors, I look at my terms over here, and I see that none of them equal this 2 in the middle. So I know that this trinomial is not factorable, so I can just leave what I have here. Now I know I have completely factored. So that's as far as I can go with that one. So now let's look at B. So let's see if there's anything I can pull out first. So I notice that each term is divisible by 7. So let's go ahead and pull that 7 out. So I'm left with 7 times the quantity x to the 4th minus 4x squared. So now I also notice I can pull out an x squared from each of these terms, right? So I pull out my x squared. Let me rewrite this. So I end up with 7, and then I pull out my x squared. So I'm left here with x squared minus 4. So the second step when I'm factoring is I want to look for my patterns, my difference of squares or my perfect trinomials. And I see that this is a difference of squares. So I know that I'm going to end up with 7x squared, and then I have my two binomials. One's going to be plus, one's going to be minus, and I know this part based on my difference of two squares. The first term in each is going to be the square root of my first term here, and the second term is going to be the square root of this second term here. So now I can just double check and make sure that I factored each piece completely, which I have, so I know that this polynomial has been factored completely. So now I'm looking to solve some of these, right? We can also use this this strategy to solve things. So when I'm solving an equation, I want to get everything to one side. So the first thing that I will do is I will subtract 10x from both sides. So now I have 2x cubed plus 8x squared minus 10x equals 0. So now that I have this, now I look and see what can I factor out of each term. So I see that each term is divisible by 2. So let's go ahead and pull that 2 out. So I end up with x cubed plus 4x squared minus 5x equals 0. So I see also that I've got some x values in here, so I can pull out an x from each term. So now I have 2x times the quantity x squared plus 4x minus 5 equals 0. So now I'm left with a simple trinomial. So I can go ahead and factor that. So I want to look at all of my factors of a negative 5. So I can have negative 1 times a positive 5, or I can have 1 times a negative 5. And that's it. So now let's add these. This gives me a positive 4, and this gives me a negative 4. And I see up here I'm looking for a positive 4, so I'm going to use these first two. So I end up with 2x times x minus 1 times x plus 5 equals 0. Right? And I get my minus 1 and my positive 5 from these two terms right here. So now that I have it completely factored, I'm going back to my zero product property because I know that anything times 0 will get me 0. So I can set up each piece that's multiplied equal to 0. So I have 2x equals 0, I have x minus 1 equals 0, and I have x plus 5 equals 0. So from there I just solve for my x. So I divide everything by 2, so x equals 0. I add 1, x equals 1, and then I subtract 5. X equals a negative 5. So I have multiple solutions for this equation. So these solutions, these are called solutions or answers or roots or zeros. Any of those words mean the same thing. So these would be my roots to that equation. So first I have to get everything to one side, and then I follow my steps to factor, and then I use my zero product property to solve for my x values. So here are a couple of monitoring progress. I want you to give these a shot and try them. So now we're going to be using that factoring to solve our real-world problems. So a terrarium in the shape of a rectangular prism has a volume of 4,608 cubic inches. Its length is more than 10 inches. The dimensions of the terrarium in terms of its width are shown. Find the length, width, and height of the terrarium. So the first thing I want to do is figure out what I'm dealing with. So I know I have a rectangular prism, and I know to find the volume of a rectangular prism, I multiply my three sides together to get the volume. So now I make my plan and I figure out, oh, I'm dealing with volume. So again, I multiply my three sides and substitute what I know. So I was given the volume of 4,608. I'm given the length is 36 minus W, the width is W, and the height is W plus 4. So I can write my equation. The next thing I do is I'm going to multiply these out, and it doesn't matter which order you multiply them in, but make sure that you get all of them multiplied together. So I end up with 32W squared plus 144W minus W cubed. So now I subtract 4,608 from both sides, right? I get everything to one side. So now I rewrite it so I can group things with common factors. So I would end up writing negative W cubed plus 32W squared plus my 144W minus 4,608. So then I want to group them. And when you're doing this, when you're rewriting and grouping, make sure that the negative sign continues to follow the term that it's with. So even though that negative W cubed was here, it's still a negative W cubed. So now I factor out what I can. So I see that there's a negative W squared in each of these. So I end up with W minus 32. And I see that there's both of these terms are divisible by 144, so I factor that out as well. So I end up with that W minus 32 times the negative W squared plus 144. So now I can factor out a negative 1 from this second part, right? Because I want to get things a little more simple. And I don't like having negatives with my squared term. So now I'm ending up with W squared minus 144. So now I always want to check everything. Do I have a difference of two squares, or do I have a perfect square trinomial? And I see here in the second binomial, I have a difference of two squares. So I can go ahead and factor this a little bit further. And I'm not done until I'm completely factored out. So now that I'm totally factored, I set everything equal to 0. So my W minus 32 equals 0, W minus 12 equals 0, and W plus 12 equals 0. So then I use my zero product property and I solve for my W. So W is a 32 or 12 or negative 12. So I know that it's not going to be this negative 12, right? Because I'm talking about lengths of sides, and I cannot have a negative length. So I can go ahead and get rid of this automatically. So I know also that the length is more than 10 inches, so I can test my solutions back in my expression for length. So I know that my length expression was given as 36 minus W. So I test both my 12 and my 32 answers, and I see which one works. And I notice that only the width of 12 works. So I know that 12 is my value of W. So I know the width is 12. I know now that the length is 24. So now I can use this W as 12 to find the height, because I was asked to find all three lengths of my terrarium. So now once I've solved for W, I've found all of the rest of what I was looking for. So here is your final monitoring progress. I want you to try this and see how you do. So now once you've tried this, I want to show you one other use for factoring by grouping. So back in lesson 7.6, we learned how to factor a trinomial where my leading coefficient was not 1. So let's look. I have 4x squared minus 19x minus 5. So the way you learned in section 7.6 was you have to make a table with all of the possible factors of my A value, and all of my possible factors of my C value, and then mix and match them until we came up with the right solution. I can also solve this and factor this by grouping. So how I do that is I take my leading coefficient and my constant, and I multiply them together. And I know that 4 times negative 5 is a negative 20. So now I come up with all of my factor pairs of a negative 20. So I have 1 times a negative 20, or I have a negative 1 times a positive 20, or I have 2 times a negative 10, or I have a negative 2 times a positive 10, or I have 4 times a negative 5, or I have a negative 4 times a positive 5. So all of these are my possible factors of a negative 20. So now let's add them just like we have done before. So here I have a negative 19, I have a positive 19, I have a negative 8, I have positive 8, I have negative 1, and I have positive 1. Well, I see here that my middle term is a negative 19. So let's go ahead and look at here, this top row. So what I'm doing here is I'm just going to break this middle term into pieces. So now I have 4x squared plus x, right? So plus my 1x minus 20x minus 5. So all I've done is I've taken this negative 19x and I've rewritten it as x minus 20x. So now I have 4 terms, and now I can factor by grouping. So I see I'm going to have a common term here, and I'm going to have something common here. So I see the thing that I can factor out of my first group is an x, so I'm going to be left with 4x plus 1. I see the common thing that I can factor out of this second group is a -5, and I'm left with 4x plus 1. So again, just like when I'm grouping, when I am given 4 terms, the things in my parentheses are the same. So that actually helps me. So now I can have x minus 5 times the quantity 4x plus 1. So this would have taken many, many more steps and many, many more things that we would have to multiply and then add and then try. But I can also factor these trinomials by grouping by just breaking this middle term into pieces that will also help me factor out. Right? So the steps that I took were, first I multiplied my a and my c, right? My leading coefficient and my constant, and that's how I got this -20. I figured out all of my factor pairs of that -20, and then I added them together, and I realized that this was my middle term, so this was how I was going to break that middle term into its 2 possibles, so then I could factor based on grouping. So that's just an extra little something that you haven't learned but can be very useful. So let's revisit our learning targets. Our first one was factoring polynomials by grouping. So in the lesson you were given polynomials with 4 terms, but at the very end you can also factor things that we've looked at, and it makes it a little easier if you use grouping. So then we factored polynomials completely, and it's really important to kind of follow your steps. So first you're going to factor out a greatest monomial, then you're going to look for any of our patterns, and then you're going to factor into, just factor the way we have before, and then we can use grouping if we haven't figured that out before. So then we looked at a terrarium and looking at volume and factoring to solve those real life problems. So now that we've looked at these learning targets and we've met and looked at examples of all of them, now I want you to work on your homework for 7.8.